Hello everyone,
Hi,
I'm Priya.
this is Amuda,
We are students of MSRIT.
studying in 8th semester of Computer Science branch.
Today we are going to demonstrate Cisco Packet Tracer. Cisco Packet Tracer is a comprehensive networking technology, a teaching and learning software developed by Cisco Systems. It's a network simulation program that allows one to experiment with network behavior.
As an integral part of learning experience, Packet Tracer offers a unique combination of realistic simulation, visualization, authoring, assessment, and multi-user collaboration and competition capabilities. Learning and teaching are made easier. Instructors use it for demonstrations, group and individual labs, games, assessments, homework, and competitions.
Packet Tracer visually simulates networking equipment, protocols and processes with real-time updates of underlying logic and activity to complement classroom equipment. Operating systems it can work on are Android, Microsoft Windows and Linux. It's available in various languages including English, Russian, German, Spanish, French and Portuguese. Today we're going to be demonstrating it in English.
Packet Tracer is commonly used by Cisco Networking Academy students working towards certification. Due to functional limitations, it is intended by Cisco to be used only as a learning aid and not as a replacement for Cisco routers and switches. Packet Tracer can be used to understand various concepts of networking with simulation. It can be used to design a network by connecting various networking devices and running various troubleshooting tests to check the connectivity and communication between networking devices.
Packet tracer can also be used to understand the use of different networking devices appropriately and the difference in their working. As it is costly to buy various networking equipment while learning networking, packet tracer can be used to understand computer networks.
Now we shall study and demonstrate the Cisco Packet Tracer. Okay, so first we need to install the Cisco Packet Tracer. For that we need to download. The version we are going to use is 6.1 right here. You can download it. And the download starts. It's about 166 MB. Okay, now that it's downloaded, we go ahead for the installation procedure. And we install it. I accept the agreement and then we give the location and hence it starts installing. Now we have completed the installation, and when we open the Cisco Packet Tracer, here we get the logical workspace, and now we can begin with the demonstration. Okay, first we are going to demonstrate Cisco Packet Tracer. To do that, we have downloaded the Cisco Packet Tracer and we have installed it. When it opens, now we are going to demonstrate a simple LAN connection. This is called a logical workspace. This is where we are going to do the different connections and analyze the network communications. First, we are going to select end devices and a generic PC. Going to select the generic PC and place it on the workspace. This is our client, and now we are going to need a switch. For that we selected switches, and in that I'm going to select 2960 Cisco switch and place it in the middle of the logical workspace. Once we are done with this, now we need a server. For that we need to select the end devices again and go to the server. Select the server and drag it to the logical workspace. Now here on the LAN we have client, server, and also the switch. Now we need to make connections, and for that we are going to use the connections, and in that copper straight through wire. We're going to select that and first click on the client and select the port fast Ethernet, and then place it on the switch and select the next available port. Now we have got a connection between the client and the switch. Now the same thing is to be done from the server to the switch. For that we are going to select the connections again, and in that copper straight through wire, and place it first on the server and connect to the port, and again select the switch and use the next available port to connect the server to the switch. And now we are going to see how these three communicate with each other, that is the client, the switch, and the server. So before we do that, let us assign these three entities some IP addresses. Now for example, let the server be given the IP address 192.168.1.254. So this is the IP address that we have assigned to the server. And similarly, for the client, I'm going to give the IP address as 192.168.1.100. So these are the IP addresses that we have assigned. Now we need to configure these entities, and first when we click on this menu pops up and we select the config here, and in that if I go to interface and I click on fast Ethernet, and in this we have to make sure that the port status is on. This has to be checked, and in IP address I give the IP address of this entity 192.168.1.100. Now the subnet mask is taken as 255.255.255.0, and once we have checked that it is on, we can close it. And now the similar thing has to be done to the server. Click on it for the menu to pop up, go to the config, and here I'm going to select the fast Ethernet 0, that is interface, and here also the port status is supposed to be on. Now once we have checked it, we need to go to the static IP address, and that has to be given accordingly 192.168.1.254, and the subnet mask is again assigned to 255.255.255.0, and now we can close it. Now to check if the client and server are able to communicate with each other, we go to client and we go to desktop, and that we select the command prompt to check if it's working, and here we type ping space the IP address of the server, since the client has to connect to the server. 1.254 is the IP address of the server. When pressed enter, we keep getting the replies from the server. So now that we know that the client can ping the server, let us try something differently by making a few changes to the server. When we select the server, let us see what services the server can provide. By selecting the services, we can see several services on the side that a server provides: HTTP, DHCP, FTP. Now HTTP is selected, and as we can see, it is on. HTTP is set to on, and this is the HTML code for the home page. And now let us try something different like FTP. Going to FTP, the service is set to on, and as you can see, there is already a username and password, Cisco and Cisco. Now let us give a different username. For example, Amuda is the username and password can be set to Priya. Now that it is set, we can select the permissions like write and read. These are the permissions, and we have to add this username and password. Now we can switch it off and back to on. We still have this username and password. And now when we go to HTTP, it is set to on. We can try different services. And now let me close it. And let us see how the client responds to various services. When we click on the client, let us go to the desktop and let us see the web server working, and let us go to this virtual web browser or the Cisco Packet Tracer web browser. This is a virtual browser where we can check. Here we're going to give the IP address as 192.168.1.254, which is the server. When we press go, there we got the HTML code that was there in the HTTP server. So HTTP is working. Now let us try FTP. For that, I'm going to go to command prompt, and here we're going to type FTP space the IP address 192.168.1.1.254. When pressed enter, it is asking for the username. Now let us try the username that we added, Amuda. It says username is okay. The password is PRIYA, Priya, and it says logged in. So FTP is also working. And now let us exit or quit from this FTP connection. And now after we have demonstrated HTTP and FTP, if we can also click on the symbol, which is a simulation panel. In this, using auto capture or just capture, we can capture the packets that go forwards and backwards and across the entities and analyze them to find the number of packets and all the other details in this panel, just like how we do in Wireshark. And now we are going to consider a new example. For that, let us work with the routers. When we select the routers, we are going to select the generic router because of its varied interfaces. Let us drag it in the workspace. And now after placing the router, we need the PCs. In the end devices, we go to the generic PC, take one PC and drag it over to the workspace. Let us take another PC and place it again in the workspace. And now we are going to connect the router to the PCs, and since there are two PCs, we can find two separate networks. And when we go to the wires, we need to take the copper crossover wire, and we will connect the router to the PC using fast Ethernet, and this back to the router and to fast Ethernet 00, and the red dots are there because the interfaces are down. And take another crossover wire and connect the PC back to the router. After connecting, it looks something like this. And now we are going to give IP addresses to the PCs. 192.168.1.100. And now for the second PC, I'm going to give the IP address as 192.168.5 100. So there are two PCs with IP addresses 1 and 5, and now we are going to configure these entities. Now that we have assigned the IP addresses to the PCs, it's time for us to configure the router. We do this by clicking on the router, and we are not going to do the command line interface, but we are going to go for config, and here we are going to select the first. We have to configure the fast Ethernet 0/0, and in this, under the IP address, we are going to type 192.168.1.1, and the subnet mask is 255.255.255.0, and the port status has to be turned to on. And now that we have done the IP address subnet mask, and also by turning on this, now the fast Ethernet 0/0 is done. Now 1/0 has to be configured too, and here the IP address is 192.168.5.1, and the subnet mask is 255.255.255.0, and now the port status has to be turned on, and the router has been configured, and now we can close it. And now that we've given the IP addresses, we can see that the wires are in green now. The router interfaces are green lines, and also the PC interfaces are also green. And now if we see the IP addresses, they're not set, and we have to configure the PCs by connecting on them. We go to desktop, and in that we go to IP configuration, and we have to select static here. The IP address has to be given as 192.168.1.100, and subnet mask is 255.255.255.0. And now let's just forget about the gateway, and we'll try to do the command prompt. We'll try to ping this PC. The command is ping, and the IP address configure is 192.168.1.1, and we are getting the reply from the router. And this is obvious as the router is connected to the PCs, but we have to give the gateway, we have to configure the gateway so that we can connect the other devices too. So this default gateway is given the value as 192.168.1.1, and DNS server we can ignore as there's no server, but it is pretty much the same thing, so let's give the same address to DNS server as well, 192.168.1.1, and yeah, it's there in static, and close it. Now let's again go to command prompt and try to ping the gateway server 192.168.1.1, and now we are also getting the reply from the gateway, so this is working. Now the same thing has to be done to the next PC. Go to its menu, go to desktop, IP configuration, see that it is selected as static. Go to the IP address, 192.168.5.100. Subnet mask is 255.255.255.0. Now again let's try the gateway by giving the valid value as 192.168. It's 5. 1, and the similar thing has to be done to DNS server 192.168.5.1. Close it. Now go to the command prompt, ping the second PC 192.168.5.1, and we are also getting the reply from the gateway. Now that we have established that the gateway communicates with the PC1 and also the PC2, the most important thing has to be seen now, that is the communication between the two PCs. To understand how the PCs communicate with each other, we have to select one of the PCs, and let's go to the desktop and the command prompt, and we'll try to ping the other PC by giving 192.168.1.100. Since we selected the 5.100 PC, we have to communicate with the other PC, that is 1. And yeah, we found out that they are already communicating and they can send packets between each other. And then let's see for the other PC too. Go to command prompt, and here we have to type ping space 192.168.5.100, and yes, we are getting the reply from the other PC. And now we have established that the PCs can also communicate with each other. And now let us see the router, and if we go to its command line interface and we press enter, we have this router symbol, and when we type enable, it goes to the privileged user mode, and here we want to see the routing table of this router. So we type show IP route, and here we've got the routing table for this router, and here you can see the symbol C, which refers to connected, and we have seen that this router is connected to fast Ethernet 0/0 and 1/0, and that is these two PCs, and the /24 suggests the subnet mask, that is 255.255.255.0, and hence when we just gave the IP addresses to the PCs and connected the routers, the router automatically knows the packets and the routes for the PCs. Now we have found out that even though we only selected the PCs and configured the IP addresses to them, the router automatically knows the path for these PCs and what path it should take to send various packets and communicate between the PCs and also between the router and the PC. So after this, the next thing we are going to do is to take another router, select the routers, and in that we'll take a generic router, select it, drag it, and drop it in the logical workspace. And the main purpose of this router is we want to establish a serial connection between the two routers. For that, we need connections, and particularly we need the serial. There are two types of serial connectors, serial DCE and serial DTE. So let us select the serial DCE for the first router, the one with the clock. So from this, let us select serial 2/0, and it connects to the second router, also to serial 2/0. The one closer to this router is serial DCE, and the one closer to the router 4 is serial DTE. They are in red dots because they are not yet configured. And now we go to the first router and we go to config. And as you can see, there are multiple options here. We need to go to serial 2/0, and here the IP address. And now that we have established the serial connection between the routers, we have to configure these routers. And let us start with router 0. When we click on it, we need to go to the config, and here, as you can see, many options. In interface, let us select the serial 2/0, and you can see all the values are still not set, and that's why we were getting the red lines. So to set the IP address, let us give it as 10.0.0.1, and the subnet mask will take the default value 255.0.0.0, and the port status has to be turned on. The clock rate is not set, and let us give it as 56K, and yeah, that is it. We shall close it and go to the next router configuration. When we click on it, we have to select config, and here also we need to select serial 2/0 since that's what we gave in while connecting. And here the IP address is 10.0.0.2, and the subnet mask will take the default value. As you know, it's 255.0.0.0, and the port status is set to on, and the clock rate is not given for this. And now we have seen that the lines have become green, that's since we have configured the routers. And now that we have configured the routers, you can see this middle router, that is router 0, has been connected to 3 different interfaces: the 2 PCs and also the router number 4. And all of them have been configured. As you can see, there are green lines everywhere. Now let us go to this router 0, and we click on that. We have to go to we have to go to command line interface, and we have to come out of this config if, and we need to press Ctrl C for that and enter. And now we've got this pound symbol which indicates privileged user. And now let us type show IP route. This is for the routing table. Yes, now as you can see, there are 3 connected devices for this gateway or the router. That is the 2 PCs, that is 192.168.1.0 and 192.168.5.0, which were already there, and now the new router, that is 10 IP address devices, that is 10.0.0.0/8, and it is showing that it's connected through serial 2/0. And thus we can show the different paths a router can take to communicate packets, send and receive the packets accordingly. And this is a simple example that we showed in Cisco Packet Tracer using routers. Thank you for watching.